All right, guys. So 16.2 is going to just be talking more about arcs, and then we're going to talk about central angles a little bit more. But mainly, this is about finding missing pieces of lines going through circles. If you look at example 1, there's a lot of things we need to find. It says find the measure of each arc in circle C and classify it. That means minor arc, major arc, or semicircle. Remember, minor arc is going to be less than 180, a semicircle is exactly 180, and a major arc is over 180. And it also says that PZ is a diameter. Okay, remember a diameter cuts our circle in half. So I think the easiest way to do this is just to kind of start off, fill out the circle, and then go back and do the rest. So it tells us a lot of stuff in the circle. I know I've got this symbol here is 90 degrees. And if you remember our central angle thing from yesterday, if that's 90 degrees, then its arc is also 90 degrees. And we know a lot because of that. Like arc MN is 25 degrees. Arc QP is 38 degrees. And arc, looks like RQ is 87 degrees. So that's already a lot of stuff. We really have to focus on these two areas up here, and we can find everything else. So the way we'd find those is using the semicircle. I know that if I have this diameter, it cuts the circle in half. And since there's 365 degrees in a circle, that means that this whole arc I just drew, that blue one, if we go like from ZMP, that has to add up to 180. And the way that helps us is we know all two of the three angles inside of that. So if I take 180 and I subtract the two pieces we know, which is 90 and 25, I get that this is going to have to be 65 degrees, which means this is also 65 degrees, or vice versa. But now we have that one. Now you can do the same thing with the other side, because this arc ZRP is also 180 degrees. So we can do 180 minus 87 minus 38. If you do that, you should get 55. So now we know pretty much everything we need. So now that it's filled out, we can just kind of go over here and fill it out as we go. It says arc PN, so be careful. That's the arc from P to N, that one right there. Looks like it's 90 degrees. And then you need to classify it, and I'll kind of come back and work on those here in a second. ZQP, from Z all the way around to Q to P, well, that was a semicircle. If you're not sure, you could add 38, 87, and 55, and they'll be 180. So 180 degrees. Let's see, RZ would be next. Looks like R to Z is 55 degrees. ZMP, let's see, from Z to M all the way around to P. Well, that's another semicircle there, so 180. Arc RM, let's see, that's from R to M. So we're going to have to add those together. It looks like 65 plus 55 would be 120 degrees. NQP, let's see, N to Q to P, so we got to be careful there. That's N all the way around to Q to P, so it's everything but this one. Well, that would be 270. Of course, you can add them up if you need to. Arc QN. So let's see, Q to P to N would get that whole one. So it looks like 38 plus 90 would be 128 degrees. And then our last one is RP. That's going to be all the way around there, R to Q to P. 87 plus 38 would be 125 degrees. Now let's go back and make sure we understand how to classify them. So 90 degrees is less than 180, so this is going to be a minor arc. 180 is a half, so a semicircle. 55 is going to be minor. Another 180, I'm going to put semicircle. 120 is going to be minor. 270 is over 180. There's our major. And then we had 128. It's going to be minor. It's less than 180, and so is 125. So classifying them is pretty easy. Just take your time. And I mean, it's a lot like finding, a missing angle in a polygon. You just have to know how many degrees there are in total and kind of work with the pieces you have. So let's look at the next one. It says find the indicated measures. We're going to have to find what x actually equals. Then we're going to have to find each of those angles. So the big thing about this is it gives us a little equation for each piece of that circle. So that's the whole way around. And you should know there's 360 degrees in a circle. So I can add all of these together and find x. I've got 3x plus 3x plus 6x. That's going to give me Oh, plus x, almost missed one, 13x. Then let's see, I've got plus 6 minus 4 minus 6. So it looks like I have 13x minus 4. And that's going to equal 360. And then we can solve that pretty easy. 13x equals 364 when I add 4 to both sides. And when I divide both sides by 13, I got x equals 28. So pretty easy. I'm going to go ahead and put that here. And now, guys, it's all about just plugging it in. But remember, whatever you get is going to be in degrees since it's asking for angles. It is asking for the actual angles, but we should know these are central angles. So whatever we get when we plug it in is what the answer is going to be. So first, angle AEB, this one right here, it's just x. So it's going to be 28 degrees. Let's see, BEC is next. BEC is this one right here. If I plug in 3 times 28 plus 6, I get 90 degrees. Now let's see CED. So this one right here, 3 times 28 minus 4. I got 80 degrees on that one. And then the last one, the big one, DEA, that'd be 6 times 28 minus 6. I got that one to be 162 degrees. So really not that tough, guys. Just a few things you need to remember. Now let's look at the next page. So more of the same. This one adds in another element, though. It says find the indicated measures in the circle, in circle P. It says ZX is a tangent. And guys, that gives us a lot of information. If this ZX is a tangent and it's touching a radius, that means this angle is 90 degrees. So I'm going to go ahead and mark that. This is 90. So I'm just going to start finding stuff just like the first one, and then we'll go back and kind of look. I think the easiest thing to realize is that this triangle, it has 180 degrees in it, and we know 2 of them. So I have 180 minus that 90 degree angle because of the tangent minus the 25 it gave us, and I got that this is 65 degrees, which means its arc is also 65 degrees. So we already found out some stuff. I know because of this central angle FPY that its arc is also 55 degrees. Angle FPD is 138, so arc FD is 138. Let's see, we don't know P yet, but I know everything else out of the 360. So 360 minus 138 minus 55 minus 65, and that gives me angle P, which it looks like would be 102 degrees, which means its arc is 102 degrees. Let's see if we missed anything. Let's go over here and fill these out. It says arc FY. Well, that's that one right there. Looks like 55 degrees. Arc YX is next. We have that marked at 65 degrees. FD is after that. That'd be 138. And then arc DX, this one right here, and we know that's 102 degrees. So not very tough. And then it's just wanting the angles. DPX, so that's this one right here. Looks like 102 degrees. It says XPY. Now be careful here. X to P to Y is this angle right here, 65 degrees. And then last is angle PXZ. PXZ would be this angle right here, which we knew because of the tangent is 90 degrees. So guys, not super tough. Of course, if you have any questions, you can ask me tomorrow in class. Good luck.